something that we didn't talk about that should be on there, it was from a couple of sections ago, but I just want to make sure you guys know how to do it. Okay. What does parallel lines mean? They never intersect. That is correct. What else does it mean? They have the same slope. So let's actually go with this problem up here. Let's say I have 2x plus 3y equals 9. Okay? And I have a point, another point. Let's say the point's 5, 4. And I say, okay, I want something that is parallel to this line that goes through this point. I want to write an equation. What do we need to have to write an equation from a couple times ago? A slope and a, or does it always have to be a y-intercept? We could have just a slope and a point, correct? By doing point slope, you guys agree? Okay, so do we have a slope? No. It's there, it's in this equation, right? Because we're looking for something parallel, right? We're looking for something parallel. So with that being the case, we need to find out what his slope is, don't we? So what should we do? Y equals mx plus b, or what we call slope-intercept form, right? So I'm going to subtract the 2x. Are we solving for y yet? We divide by 3. Okay, so that's the equation of that line. But once again, what did I ask for? An equation that is parallel to this line that goes through that point, correct? So therefore, what do we know about the slope? As you brought up, it should be the same, correct? If they're parallel, they should be the same. So the slope that I'll be using is negative 2/3. Does that make sense to everybody? I believe that point was 5,4, was it not? Okay. So now we have a slope and we have a point, don't we? So what can we do? We're going to do point slope, where we just plug and chug, right? Anybody remember the formula just so it's off the top of your head? Y minus y1 equals slope times x minus x1. Remember, that's something I would probably suggest that you memorize, correct? Or, once again, we've talked about just using y equals mx plus b and situating it within that, right? I personally like to use this just because I think that's what was taught to me when I was younger. Brittany? When I have a point and a slope, to be honest, because it's called point slope form, right? Kind of tells you when to use it. Now, if I have that point is a y-intercept, would I be using this? Nope, but remember, a y-intercept is when x is 0. And notice I don't have that. I have a 0.54, so it's not the y-intercept. Does that answer your question? If I had my y-intercept, I just plug it in using slope-intercept, but I don't have it. No, ma'am. Because what this represents, the x1 and y1, comes from just picking a point. Now, what if I had 2 points? Let's just bring that up again. What can I do with 2 points? First off, I'm going to find what? Slope. Okay, after I find the slope, I have 2 points to pick from. Shouldn't matter which point I pick. Nope, as long as I pick one of them and plug it in, same answer. Does that answer your question? Thank you, Brittany. Okay, so this is just a plug and chug. Y minus 4 equals negative 2/3 x minus 5. So this one's not going to come out pretty because of the fraction here. Okay, sometimes it does, but in this case I just made it up so it's not so pretty. So as I distribute it through, y minus 4 equals negative 2/3 x. How do we multiply fractions? Straight across, right? So underneath this 5 is a 1, so I notice have a 10/3, don't I? Okay, could you have fractions on your test? You can, so just be aware of them. Don't be scared of them. Okay? Then we're going to add 4. But me personally, I already come right here and I just say adding 4 is 12/3. Because what's 12 divided by 3? 4. So did I change the value of it? Just made it look a little different, right? So I'm adding 12/3. So our equation that is parallel going through that point is such. We got the sniffle brigade already.
Wait, what did you do?
Well, because once again, I'm adding 4 to 10/3. Am I not, Landon? Okay. But once again, when I add fractions, what do I have to have? Common denominator. So I already got the common denominator with it. So I did 10/3 plus the 12/3 to give me 20/3. Does that answer your question? I just did it before I got over on the other side. Okay. What about using that same graph? Once again, what was that same equation that we had at the very beginning? Equals 9. So we came out to be y equals -2/3 x plus 3 after we did so, right? Using that same point, 5, 4, and using this time I'm going to say I would like an equation of a line that is perpendicular to that line that goes through that point. Can anybody remember what you do when you have a perpendicular line? So we reciprocal. Is it just the reciprocal? The opposite reciprocal. Okay, so what's our slope? -2/3. So when I do it, what is it going to be? +3/2. Does that make sense when it's perpendicular? You do the negative reciprocal or opposite reciprocal. Okay, so notice my slope in this case, just as Walker just said, was 3/2. So Brittany, once again, since you asked, I have a slope and a point and a slope. What am I going to use? Point slope. Does that make sense? Okay. So once again, that's y minus y1 equals slope times x minus x1. Okay. Now it's just a plug and chug again, correct? Y minus 4 equals 3/2 x minus 5. Distribute it through. So Landon, when I add 4 over, what am I going to do this time? Add how much? Onto the -15/2. So I'm going to need a common denominator. So what would I just be doing? Adding what? I'll be adding 8/2, right? Does that make sense, everybody?
Sorry, not negative.
Not negative because I'm adding them over the other side. I'm just skipping that step instead of just putting the 4 there, then getting the common. I'm already doing the common denominator, right? So y equals 3/2 x minus 7. So that line would be perpendicular going through the point 5, 4, right? Isn't there an infinite amount of lines that are perpendicular to that line? But there's only one line that's perpendicular that goes through that. Okay? Is everybody with me on that? That's just kind of stuff that double wink, wink, hint, hint, really to know. Give you a little winks here. I'm not a very good winker. Okay? But I would highly suggest you put something around that to study that. I don't know why, but somewhere you might see it later, maybe on Monday, whatever. Is that enough hint? We good now? Okay. Awesome. Fun time. Okay, let's do what we're going to do today, which is 4-1. Okay? 4-1. So today, we're doing what we call a system of equations. Okay? System of equations. What is a system? Remember, that's when we have more than one equation. We just did system of inequalities, did we not? For once again, we're finding the values for where it works for both equations. So that's the same thing that we're going to be doing today. Okay? We'll be trying to go ahead and do a system of equations. Now we have three different styles to go ahead and do a system of equations. Okay, we have three styles. One, we have substitution. Two, we have graphing, which is the worst one, in my opinion. And three, we have elimination. So I'll be going over all three of those just to be making sure. Okay? So let's start right here. Okay? I'm going to do this in two different fashions. One, I'm going to do this via graphing. Two, I'm going to do this via substitution. Okay? Now, we should have seen these in the past, but once again, I'm taking it for granted that you've never seen these before. Okay? Does that make sense? So, here we go. Let's start with the graphing one. I'm going to start with this guy first, and I'm going to do him in black. Okay, where do we start at? You should know this because you just did all this stuff, right? Graphing, where do we start at? The y-intercept. Notice I'm going to rise to run 1. Now, ladies and gentlemen, in normal, where have I usually been? How many points did I want? 3. When you're trying to solve via graphing, keep going until you freaking get all the points on the chart, okay? Because you're trying to find out where they intersect. And we all know that if I graph it by hand, is it the most exact graph? Not really, right? I'm trying my best, and 3 points usually gets us a pretty good line. But once again, does it represent exactly what we can see by using our tick marks and everything? Probably not. So I would continue to get some more points up here. Okay? So I'm going to still rise 2, run 1, rise 2, run 1. We'll see where we're at, and if I need to, I'll plot some more points. Okay? I'm going to do this guy in red. Now, actually, let's do it in purple, just because of that. So, would that be a great graph to do by the intercepts? The y-intercept's pretty easy. It's 10, right? What's the x-intercept? 10/3, which is 3 1/3. Is that the most exact way to graph that, probably? So what should I do? Maybe say y equals -3x plus 10. Okay. Y-intercepts here. I'm going to be going down 3 over 1. Down 3 over 1. Down 3 over 1. See, notice, guys, did I line up on a point that I already used in the past? You see how this is a point, exactly the same point on that line as well, which is 3, 1. That's why it's important to use more than just 3, because then I might land on the point that I've already used. Does that make sense? Personally, ladies and gentlemen, I hate this way. I hate graphing to do a system of equations because you have to be so accurate. It takes a lot of tedious time, in my opinion. So this is not my favorite, but is it something that you might have to do? Yes. Okay. So I would highly suggest you just plot a lot of points using your slope until you get through your full graph type of a thing and find out where they intersect. Okay. Now, does every graph always intersect? What are those things that are called that they don't intersect? We talked about them. Parallel lines, they should have the same slope, right? You see that they have the same slope, will they ever intersect? Nope, so that's called a no solution, right? Because you'll never find something that they both equal to. Okay, so we did that one via graphing. Now I'm going to show you how to do it via substitution. Was it 2x minus 5? That one was. Thank you. Okay. So, ladies and gentlemen, we know unless they are parallel, sooner or later they're going to intersect, right? That's the definition of parallel. The only time they cannot intersect is if they are parallel. So if these two lines are not parallel, they will intersect sooner or later. That means there is a place where the x and y value are the same, right? There's only one place that they're the same, correct? So that means that this y is the same as that y somewhere, correct? Well, what does y equal? So what can I substitute in? 2x minus 5. So I have, 3x, but I see a y. What can I do? Substitute it in. So I put plus. I like to put parentheses around it whenever I substitute something in. Just in case, like, let's say, for example, this was a 2y, then I would understand to distribute that through, correct? Okay, equals 10. Notice because there's no variable in front of my substitution, I can just drop it. Hopefully I'm not, if I'm going too fast, guys, please slow me down, okay? I don't try to, just sometimes I get going, everybody's talking to me, so I keep going. Does that make sense? So I have 5x minus 5 equals 10, or 5x equals 15. So end all be all, what's x? 3. Right? So I know my x value. Isn't that what I had on my graphing part, that x was 3 as well? Okay. So now where am I going to plug it in? Does it matter? I can plug it in the top or I can plug it in the bottom one, right? Doesn't matter. But why am I going to probably plug it into the bottom one already? It's already solved for y, correct? So that's where I'm going to go. So I have y equals 2 times 3 minus 5. 6 minus 5, y is 1, so the coordinate is 3, 1. Yes, ma'am. Right here, on this one up here, I had, because x was 3, right? So I plugged 3 in for x. Now if I did it into the top one, it would be the same as well. If you'll notice really quick, 3 times 3 plus y equals 10. 9 plus y equals 10. Subtract the 9, y equals 1. I can plug it in either order. And notice I have the coordinate where those guys graphed each other last time as well, correct? Any questions there? That's substitution. Okay? The only time I would do substitution is when something's already solved for a variable. That's the only time I would do substitution. Okay? If you already have something solved for a variable, nice. It's pretty easy going. But, okay, what if, I'm going to come back to this exact same equation, but just write it a little bit differently. I had 3x plus y equals 10, correct? And the other one was y equals 2x minus 5. So let's say negative 2x plus y equals negative 5. Would that be correct if I added and subtracted the 2x to the other side? Okay. These ones are both in standard form. Okay. If you ever have both in standard form, the easiest way to do that problem is elimination. Okay. That's where you go ahead and add 2 rows together to eliminate a variable. Make sense? So right now, if I add these 2 rows together, would I eliminate a variable? 3x minus 2x is still x, right? Y plus y is 2y, and then I'd get 5. Did I eliminate a variable? No. But if I manipulate this bottom or top, I don't care, I'm going to do the bottom. I'm going to times the whole thing by -1. Does that change the value of my equation by multiplying by -1?
Well, it
Doesn't change, it's an equivalent expression, I should say, right? Or equivalent equation. You guys agree with me on that? So when I do so, I get 2x minus y equals 5. You guys all agree that that's the same? Okay. So let's go ahead and do so. I'm going to add these two rows together. 3x plus 2x is 5x. Y minus y is 0. That's the whole goal, is to eliminate a variable. 10 plus 5 is 15. Notice x is 3, which has been consistent once we've done all three ways now, right? Okay. Now, once again, I know what my x value is, so I can plug it into this guy or this guy. It doesn't matter which equation you plug it into. Sometimes I like to plug it into both because I should get the same result, right? If I don't get the same result, did I get the correct x value? I didn't. So, doing so, I get 9 plus y equals 10 because I plugged 3 in correct. So y is 1. I'm just checking how many times you actually have to graph. I think you only have to graph 4 times. And then the rest of them are your choice. Okay? Ready for another one? Yes, Mr. Anderson, I'm ready. Thanks, guys. Appreciate you too. All right. We good to move on? Anybody need time? All right. From what I just said, what method would you guys choose? I personally would do elimination. Okay, because they're both already in standard form. Is it kind of an easy way to do substitution if I need to? What's probably the variable I would use if I was going to do substitution? I would solve for that y right there, right? And then I can substitute in this equation. But if it's in this form, me personally, I'm going to go for elimination. Can I add these two rows right now and something cancels out? I would get x plus 4y equals 8, right? So would it work? Nope. So I need to manipulate an equation. Which equation should I manipulate? Top and multiply it by what? Does everybody understand why I'm multiplying by -3? Because that would give me a -3y. When I add it to 3y, it would eliminate, correct? Hi. Answer for me. Back to that. You might be back to that. Okay, so once again, we're going to be multiplying the top row by -3. So that's -9x minus 3y equals 27. Any questions on how I got that result? So I go ahead and add them. Those guys are gone. So therefore, x is -4. Does it matter what you quit? Is it in either of those? Let me just take a look with the internet. You're just ready to do it. You should have done it. So I personally am going to probably put it in the top equation because y is already solved for. That's me. But would it matter which one? Shouldn't. So I have negative 12 plus y equals negative 9. So I'm getting y equals 3. Is that what you guys got? So the coordinate 4, 3. How could you check your work if you wanted to? By plugging it back in, notice 12 plus, negative 12 plus 3 gives me negative 9. Negative it's a negative 4. 8 plus 9 is 17, right? So I can check it back in and see if it works. For some reason, these style kids always struggle with. Let me find one. Okay, what method could I use? Somebody said it, just gotta say it louder. Substitution, right? Why? Something's already solved for, correct? So once again, that's saying that this y is sooner or later equal to that y somewhere, correct? Because once again, are they same slope? They're not the same slope, right? Because they're not the same slope, I know that they will intersect, right? So once again, I can replace this 3x in for that y. Is everybody there with me? Oops. I was doing the next step already in my head. Just use substitution there, correct? Gonna go ahead and add it over. X equals 1. I'm going to plug it into either one. I believe the top one worked the best for me. So y is 3. I plug 1 in. 3 times 1 is 3. Okay. I'm going to do a quick one right here. Okay, so which system are we going to do? How are we going to solve this? Everyone do it via graphing. Good, I'm glad nobody raised their hand. Everyone do it via substitution. Great, I wouldn't do that either. How about elimination? Yeah, I got like 5 hands. Good, out of 30. That's awesome. Okay, so once again, I'm going to go ahead and graph this. Now, can I eliminate, not graph, oh, I just said graph, not graphing it. I'm going to use elimination method. Can I eliminate any variable just by adding the rows right now? No, I need to manipulate, correct? When I manipulate, what do I need to do? Times the top by 2, because I already have a negative sign when I have a positive. So I'm just going to times him by 2, which I get 4x plus 8y equals 12. When I add that, I get 0 equals 19, correct? No variables on the left, and it equals 19. What does that mean? This one's a no solution. And if I got these into y equals mx plus b, they would both have the same slope. Okay? Any questions on that one? Okay, I'd like to do another one of that style. What am I going to times the top row by? 2. Notice I get 6x plus 2y equals 2, and I get 0 equals 0. So if I get a 0 equals 0, what kind of solution is that? Infinite. And the reason why is because they're right on top of each other. It's the exact same equation. So is it all real solutions, though? Can I pick any value for x and any value for y to make that work? Let's plug in 4, 5. 3 times 4 is 12, plus 5, does that equal 1? So that point didn't work, did it? Still has to be a point on the line. So what we do is we call this infinite solutions. Okay? There is infinite solutions. And we're going to show you how to find those infinite solutions. So what I do is, what's the easiest variable to solve for? The y on the top is the easiest one to solve for. Would you guys agree? What does y equal? Negative 3x plus 1. Okay? Here's how a solution should look for an infinite solution. Okay? I can have a value x, but the y value works such that it goes in this equation. So let's pick out any x value. Kendra, can you give me any x value? Yep, any number. 6 it is. So she chose 6. So what would be the accompanying y value for that? Notice I plugged 6 in for this x. So what would I do in this one? Plug in 6. So that's negative 3 times 6, which is negative 17. I mean negative 18 plus 1, which is negative 17. This point would be a point on that line. Okay? So therefore, notice I put a value in for x, and notice y in terms of x. So what does y equal? It equals negative 3x plus 1. Notice how both variables, x and the y variable, are in terms of x. Is this the only solution I have? I could do it solving for y. So meaning, let's actually get x by himself here. So I have 3x equals negative y plus 1. Divide negative a third y plus a third, if you'll notice that. Okay, so what if I wanted to use that equation instead? Notice I would say, okay, y is the value I'm going to plug in, and I think would have negative a third y plus a third. Let's see if I plug that in, it still works. Let's plug in negative 17. So I plug in negative 17. Negative a third times negative 17 becomes 17 thirds plus a third. That's 18 thirds, right? What is 18 thirds? 6. Still uses that point. So does it matter which variable you solve for? The book might just show, the answers.
I believe I showed both ways. But this is in the future, you can show either way. It doesn't matter what variable you solve for.
Okay, but notice, see, I solve for x, so which variable am I going to use? Y, because this is in terms of y. Does that make sense? Not good. Yes, Brittany, thank you. I want it as one of these two ways. So you can say infinite, but then it needs to have one of these. Is that answer? Because what are the possibilities for these infinite solutions? Well, these infinite solutions have to represent these values. Because once again, what values could I plug in for x? Hence the infinite amount of numbers, right? And then the y comes along because of the x value. Or as here, infinite amount of values for y, but the x value comes along with whatever the y is. Nope, just one or the other. Whatever's easiest. I just want to show you both ways. Because sometimes x is the easiest, y is the easiest thing to solve for, and sometimes x is. So I want to be aware that you could do it either way. Just to be honest, solve for a variable, and whatever's the easiest one to solve for, that's the one I would do. So notice x was not as easy to solve for. So this solution kind of sucked more than this one did. So I probably just went with it. Answer your question. Okay, now if you guys will notice, every time so far, we've only had to manipulate one row when we did elimination, correct? To make it look like another. Is that always going to be the case, such as this fella? Notice, can I just manipulate one row to make him look like another row? Not as pretty, right? So I have to manipulate two rows, don't I? Okay, I'm going to look and say, all right, first off, I can look at the x's. Now, if they're both positives or both negatives, I will look at the y values next and see if they're opposites. Because I don't want to have to times by a negative unless I have to. Okay? So in this case, because the x's and the y's both have opposite signs, does it really matter which one I'm going to go for? No. So what would you guys rather get rid of, the x's or the y's? Doesn't matter. Let's get rid of the y's. Okay. So we're going with y's because that's what, tell me your name again. Tyler Fisher. Okay, said. So what do I need to multiply the top by? Because I want to know where 2 and 3 meet up. Where do they meet up? 6. So I'm going to times him by 2. What am I going to, and that gives me negative 6x plus 4y equals 6. What am I going to multiply the bottom row by? Oh, sorry. Yeah, I'm an idiot. Why do I have to be an idiot? Sometimes I am, okay? It is what it is. But we're going to turn that into a 3. Okay? We're going to do him in black. Here we go. Negative 9x plus 6y equals 9. Thank you for giving me a dirty look earlier because I was there and you're like, what the hell just happened? Right? The bottom one I'm going to multiply by 2, which I get 8x minus 6y equals negative 12. Does that feel better? So when I add those rows, now can I eliminate a variable? Yes. And then once again, I'd go plug it back in, one of those. I'll do the bottom one. So the coordinate is 3, 6. All right, you ready? Still good there? Okay, that's just 4-1, which I kind of went through every style you could have. Now we're going to go to 4-3. And yeah, we're going to try and do our best to get through as much as we can on this. If it takes over that we need to go into the next time's lesson, I'll just adjust your homework and we can do it with the next one. Next lesson is just one section, 4-2, but story problems, completely story problems. So we'll be looking at those, but this one takes a little bit of time. If you guys need me to go over it more in the next class as well, just please tell me we can do more examples, okay? All right. This guy is still a system of equations, but three. All right. So this time, we have 3 variables. Has anybody ever worked with 3 variables before? A few of you? Okay. So notice, how many equations did I have 2 variables? I have to have 2. If I have 3 variables, I have to have a minimum of 3. Okay? Must. If I have 4 variables, how many variables should I have? 4 equations. Does that make sense, everybody? You have to have the same amount of equations as there are variables you're searching for. Okay? All right. So we're going to do the same thing. Basically, what we're going to do is we're going to let one equation just stay the same. And then we're going to use that basic equation to then eliminate the other two. Okay? And what that does is it allows us to get down into a 2 by 2 again. And that's just what we just solved for in the 4-1 is 2 by 2. Two equations, two unknowns. So looking up here, which variable is probably going to be the easiest to get rid of? Is there any of them that just add together and they get rid of something? Not right now, huh? I have to manipulate some, don't I? Okay. How about I go, this is guys going to be row 1, row 2, row 3. Okay. How about I go ahead and say, I'm going to multiply row 2 by 3 and add that to row 1. See what that means? Why am I timesing this row by 3? Because then when I add that row to row 1, what will eliminate? The y's would, wouldn't they? Does that make sense to everybody? Everybody with me on that? Okay, so doing so, if I multiply that, that becomes 9x minus 3y plus 18z equals 36. So that's 3 row 2. That's basically what this is. Now, I'm going to add that to row 1. What do I get when I add that to row 1? X plus 9x is 10x. 3y minus 3y is 0, which was our goal, correct? Z plus 18z is 19z. 8 plus 36 is 44. Any questions on how I received that black one, which is equivalent here to that manipulation, right? With me? Okay, so now notice what variable is missing down in this equation? Y. So what variable do I want to eliminate again? Y. So that I just have x's and z's, because then it's just like what we just did in the previous problems, right? So my next one that I'm going to do, okay, is I'm going to multiply this row by what? 3 again, am I not? Because he's negative y. So I'm going to go 3 times row 3 and add that to row 1. If I multiply row 3 by 3, that gives me a negative 3 here, doesn't it? So that when I add it to row 1, would the y's cancel out again? It would. Are you a turkey yet? A chicken. Chickens or turkeys? Uh-huh. This one right here? I multiplied this row by 3. I wrote it just right above it. Because notice 3 times 3 is 9, negative 1 times 3 is, Does that make sense? So in this case, I'm going to do it in the purple right here, Brittany. I'm going to multiply this whole row by 3. So I get negative 12x minus 3y plus 9z equals negative 3. With me on that? Is everybody okay? Okay, so when I add those together, notice I get x minus 12x. So that's negative 11x, right? With me on that? 3y minus 3y, 0y. That was our goal, wasn't it? Z plus 9z. Oh, did I miss? Oh, shoot. Sorry. I need to split lessons, but it's not going to happen. I swear I really know how to times. I do. But I'm messing up today. So that's 7z. And then 8 minus 3 is 5. Does that guy look fun to play with? Nope, but we're going to do it anyway. Okay, so to be honest, when it comes up this nasty, I might have been able to choose another variable. What's another variable that would have been nice to get rid of? Z's wouldn't have been bad because that's Z, 6Z, 2Z. That's not that bad. Even the X's weren't that bad, right? But I just saw Y, and that's the one I decided to go with. Can I still do the problem? It's still going to be okay. Okay? Hopefully this guy comes out nice because they don't have it, but I just looked at it. We're going to do it even if it's nasty. Right, Hookie? Have you ever been Rufio for Halloween? That'd be kind of funny because you look. No? Okay. Anybody get the reference? I don't even know what the hell that is. Okay. I'm going to multiply the top by what? Anybody? I don't need to do negative 11 because it's already negative here, so I just need to times him by 11. How about the bottom row? What am I going to multiply him by? 10. The reason I know, sorry. I believe I did my multiplication right. I was just waiting. He's usually my calculator guy, but he's doing other things today. Am I really that boring? Would you like me to show you? I will tell you. You ready? What's 11 times 40? 440. Because it's just 4 times 11. What's 11 times 4? 44. So 440 plus 44. Yeah. The distributive process. Okay, this guy we get negative 110x plus 70z equals 50. I hope this comes out really nice. 279z equals oh, he's not nice, is he? This was a piss poor one to pick the first one. I did everything multiplying right this time, right? I didn't mess up. Sometimes I know. I mess up. Was 19 times 11, 209? All right. Yay. That doesn't go into it nicely, does it? Almost, but it's not, huh? That sucks. Then what would you guys do here? I'm not going to keep going on this one because I don't want, you guys are like, this sucks. I'm going to make sure you guys understand a nice, easy one. But what would you do here? Just let's talk about it. You take him and do what? Plug it in for z, and then you're going to solve for what? X. And then now you're going to have x and z. Then you're going to come up here and plug it in for x and z and solve for y. That one, you're not going to ever get one that nasty. I promise. I'm not going to assign one that bad. Okay? Because that just gives you like nightmares. I'm telling you. I like math and that gives me nightmares. Okay, so let's just do one that's nicer. I'm sorry. I should have picked that better one. You guys are like, no, it ain't one. All right. Okay, this one should be good. Yes. Okay. We have a couple options that are the variables are pretty easy to get rid of. Which ones are pretty easy to get rid of? The y is pretty nice. Who else? Z is pretty nice. X I have to manipulate a little bit more. He's not bad, but I would have to do more work, correct? Okay. How about let's do y's. Is that okay again? Just because these two are right next to each other. So what am I going to do? I'm going to add row 1 to row 2, and I'm not going to have to manipulate it whatsoever, correct? Everybody agree with me on that? Okay, so if I add row 1 and row 2, I get 3x plus z equals 7. Any questions on how I got that? Okay, so what variable do I want to eliminate again? Y. Now notice, this was using row 1 and row 2. So what do I have to use to get rid of the other one? I either have to use row 1 and row 3, or row 2 and row 3. Does that make sense? Does it matter which one? No. Is there a better one to use? I'd probably go row 2 and row 3 for the fact of the matter, he's already negative. With me on that? So what am I going to have to do to manipulate row 2 to get rid of the y in row 3? Times by 2, right? So I'm going to go 2 times row 2 plus row 3. That's the goal. When I multiply him by 2, I get 4x minus 2y plus 4z, I'm making sure, equals 16. Notice when I add that together, I get 4x minus 3x, which is just x. Negative 2y plus 2y is gone, which we wanted. 4z plus z is 5z. 16 minus 9 is 7. So everybody understand where I'm getting that, though? If you don't understand, it's just there. I don't know if you're going to get it. So make sure you're understanding what I did there. Okay, so now we're down to here. This one's a little bit nicer to play with, isn't it? Okay. Solars, that, right? Did I get it? Okay, what am I going to multiply? Which row do you want to get rid of? X's or Z's? Okay, so the top one or the bottom one am I going to manipulate? 5? Good. Does everybody understand how Zach worked through that? He decided to get rid of that, so I'd have negative 3x minus 15z equals negative 21. I believe I did that correct. Just don't trust myself to get taught me. When I add them, I get 0 x's minus 14z equals negative 14. So what does z equal? Equals 1, right? Z equals 1. Okay. So now what am I going to go do? I'm going to plug it into one of these guys. Well, this guy already has x by himself, so I'll probably plug it into this one. So I have x plus 5 equals 7. So x is who? X is 2. With me? Just plug it in, Brittany. It doesn't matter. Yep, I'd go into one of these two first so that I can get the other variable. I will now go up to the top because I have 2 of the 3, so therefore now I'll have this one variable to solve for. Does that make sense why I'd go here first? Okay, which one's probably the easiest one to solve for? Let's go up to the very top and see how y is by himself. So I'll probably go there. So I have x, which is 2, plus y minus 1 equals negative 1, which is 1 plus y equals negative 1. Y is negative 2. So the coordinate is 2 comma negative 2 comma 1. They do it in terms of x, y, z. Okay? I would like to do one more, but I'd like to give you your homework just one more time before we go. So if we run out of time, but once again, I'm more than welcome to go ahead and work on some more examples in this one next time if we need to. Let's do, I think odds are completely fine on that whole section. So on 4-1, do the odd. 4-3, do the odd. If you can, I would suggest you do 48 as well, just to get practice with story problems. Because once again, that's not everybody's forte, right? The story problems, so work on that. I'd like to try another one. Just because I don't know, mean times are always getting a little bit, so at least we have the problems that we're working on, correct? Once again, I will be putting them online probably during next period because I have time to get out and scan it and go from there. Yes, ma'am. I would suggest you do 48. Let's put 48 on there as well. Just because story problems are a good thing. I know that that's some practice, and I know there's something on there that you probably want to keep practicing. Okay. I don't know why that does that. Tell me your name again. Kennedy Davis. Saw you were on a poster last week. Is that correct? All right. Kennedy, which variable do you think is a nice one to get rid of? Y is a good one. Or, who else is also a good one? Z would be because I could just add some rows together. Yes, sir. It is. Sorry. Let's erase that and make it prettier. Okay. All right. I'm going to get rid of Z's because we've the last 2 times got rid of Y's. So I'm going to do Z's this time. What 2 rows should I add together first? First and third, just because they're already opposites, correct? Okay. So they're first and third. So I'm going to go ahead and say, all right, I have negative x. This is, by the way, row 1 plus row 3. I have negative x plus y equals 7. Well, what would I need to do to get rid of another z? Okay, so row 2 with either these guys or this guy. I probably will go 2 and 3 because he's already negative and he's positive. Does everybody understand why I will go with 2 and 3? What do I need to multiply this by, Chloe? So I'm going to go 3 to row 2 and add that to row 3. Which I get really quickly, that's timesing by 3, so that's 9x plus 6y minus 3z equals negative 27. Everybody see what I did there? 9x minus 2x is 7x. 6y minus y, 5y. Negative 27 plus 26 is -1. Are we okay there? Walker, which one would you get rid of on this one? Good. So what are you going to times it by? Good. So I get -7x plus 7y equals 49. Does everybody understand where that's coming from? When I add those together, I get 12y equals 48. So y is 4. Okay. Then I plug it back into, as Brittany said, probably one of these two, right? So I can get the x value. I'm probably going to plug it into this one. So I have -x plus 4 equals 7. -x equals 3, so x is -3. Then what? Plug it back into one on the top. So I'm looking for where z's kind of nice. He's probably the nicest one here, isn't he? So 3 times -3 is -9, plus 2 times 4 is 8, minus z equals -9. That's -1 minus z equals -9. Negative z equals -8, so z is 8. So I have -3, 4, 8. Okay, guys, thank you. Let me know if we need to go more examples into that one next time. If we need some, let me know, okay?